All right, so we've got the potential energy figured out. Time to move on to kinetic. So a half, no problem. That's just a constant, easy. 0.5 in your calculator. The mass, exactly the same mass we already measured. So this is the mass in kilograms. Don't be confused and think that's a meter, okay? A little bit different, a little confusing there. So this is the mass in kilograms, which we already calculated as 0.0316 kilograms. So that's the same. The only difference here is we're not gonna use the 9.8 and we have to figure out the velocity of that falling pipe. So remember what velocity is. So velocity is distance over time. And what we're talking about is the little pipe. So the distance is actually going to be the length of this little guy. Okay? That's the distance that's going to go in here. So length of small pipe. Okay, this isn't the height above the ground like we did over with potential energy. It's this guy. And then the corresponding time is going to be the time recorded by the photo gates that we talked about earlier. Okay? Photo gates. Okay, so the length of the small pipe divided by the time measured by the photo gates. So let's start by measuring the length of this small pipe. So we've got our little ruler over here. And let's see if, let's do it over here where we can kind of see. So I'm gonna line this up really, really carefully so that the very first mark on the ruler is lined up perfectly with the edge of the pipe, okay? So I need to look straight down on it like this and take my measurement. So I'm just gonna touch it right here. And so again, these are centimeters right here, and these are millimeters in between. So it looks like I have 7.5 centimeters for the length of this pipe. 7.5 centimeters, okay? Again, it's kind of a weird thing where it gets a little distorted by the camera. But what I don't want to do is I don't want to try to measure it like this. What's the problem with this? If I look carefully at the bottom, there's a whole bunch of plastic at the end of the ruler, probably close to a half a centimeter. So this is going to give me a completely wrong answer for the length of the pipe. So I got to be really careful and make sure that I start my measurement where the actual ruler, the measurements on the ruler start, right there. Okay? All right, so with that, it looks like it's exactly 7.5 centimeters or 75 millimeters, okay? So 7.5 centimeters. Oh, we have the same problem that we had earlier. Centimeters are worthless in this formula, okay? We have to convert this into meters. So how many meters are there per centimeter? Or how many centimeters are in a meter? It was 100, right? So let's write this up here, and let's do that same dimensional analysis where we kind of figure this out. So 7.5 centimeters. Now again, I can put a placeholder under there just to make the math a little more evident. And then we're going to multiply this times this ratio where I go, well, there are, for every 1 meter, there are 100 centimeters. Okay? So again, centimeters go away and I'm left with the units that I want. What does this do to the decimal? Okay, so I started with 7.5. I'm dividing by 100. So what does that do? That moves my decimal 2 places to the left. So this is going to be 0.075 meters. So there is the length of my small pipe in meters. I'm ready to go over here with my velocity calculation. Now all I need is my time, okay? The times at these locations. So let's do that. Let's take a break here and then we'll come back and I'll put that stuff up there. So let me erase